Yes, so let us see the multiprocessor. Let us see now the multiprocessor network topologies. So the multi-core chips required a network on the chip to connect the cores together. These cores, they are nothing but the multiple processors, and these multiple processors, they need to connect or they need to fetch data or instructions from the memory, which is shared memory. And because multiple processors, they need to communicate with the multiple modules of the memory. So you need to have a network that is connecting these particular processors with the memory. So this particular network includes the switches, the number of links on a switch to connect to the network, the width of that particular communication path also matters. So sometimes that is less number of bits, sometimes it is higher number of bits. So the speed of transfer of the data is governed by the number of bits at a time, how much data can be communicated. Length of the link when the network is mapped into the chip. These networks are normally drawn as graphs with each arc of the graph representing a link of communication network. Okay, so usually on the graphs we draw a node and uh, the path between the nodes through which the communication can happen. These nodes may represent either the processor or they may represent the memory modules. The memory modules and the processors may be represented by using the different types of icons to identify that some nodes are the processor nodes, whereas the other nodes, they are the memory nodes. Uh, so to show a typical arrangement of connection between the nodes, so you can have either a bus topology or you can have a ring topology. In the bus topology, there is a common bus, and to that particular common bus, the memory as well as the processors are connected. And at a given time, there can be only one processor using that particular bus, and uh, the other processors, they will wait for the processor using that particular bus to finish its job or to finish its communication, and the next processor comes in. So that is the simplest topology. The ring topology, whereas it consists of connection between the nearby processors, and so one processor, it communicates with the next processor preceding and the next processor. So this ring topology is also used somewhere, but in this case, even if some processor is not concerned with the data, uh, it may be required by the other processor, but still it need to just forward that particular data from the previous node to the next node. So a lot of overhead is there in this particular ring topology, though there is simultaneous operation in this particular ring topology. Uh, when we talk about the network, then the network, it may be incomplete network or it may be fully connected network. Okay. In case of fully connected network, the processor memory nodes are connected they are dedicated to each other. That means every processor is connected to the memory. Okay, so for example, the start topology, in that uh, every node is connected to the memory, and in that case dedicated paths are there, but such network is very complex network. Lot of communication links paths are required between the processor and the memory for this particular purpose. You can have various types of interconnected network between the nodes. So one type is this 2D grid or the mesh of 16 nodes. So you can see they are connected in this particular of mesh is formed of 16 nodes, and they are connected in this particular fashion. So they are connected. The ring is formed here horizontally also, and vertically also, and so that there is uh, less amount of you can say uh, uh, the when connection is to be made, then the connection from any node can be made to any other node in this case. Okay, so this particular arrangement of interconnection between the nodes is called the mesh arrangement. You can have the cube kind of arrangement. So this is a node or the interconnection or in the cube form, and there are 8 nodes in this. So like that you can have the n cube model. So in this particular model, the value of n is 3. So there will be 8 nodes. Whereas if the value of n is 4, then there will be 2 to the power 4, that is 16 nodes, and in that case the nodes, they will be interconnected to each other. Okay, so there will be 2 such cubes, and there will be connection between the one cube and the other cube to form the 2 to the to form the n cube. Okay, so you can have the structure like this. Then this is the crossbar network. So to connect between uh, the processors. So crossbar, it stands for there are 8 horizontal lines and 8 vertical lines, and at each of the cross, okay, wherever these horizontal and vertical lines are crossing each other, then you have a switch over there. Okay, so this particular crossbar network. Okay, so with this, it is possible for any processor to connect with any other processor. There can be multiple connections at a time. Of course, if in those multiple connections, different pairs of processors are involved. Uh, every time it is not necessary that the connections are made, or the nodes are always processors. So some of the nodes, they can be memory elements also, but here what is shown is the all the nodes are shown to be the processors. So depending on the required communication path, one processor gets connected to, or one node gets connected to the other node. So this is the crossbar uh, network. Okay, so it is a kind of fully connected network. Okay, then the omega network. So the difference between the crossbar network and the omega network is that it makes use of less number of switches than the crossbar network. So that way crossbar network is expensive, requiring more number of switches, whereas here you have less number of switches in the omega network. For example, in the first level you have 4 switches, in the second level again you have 4 switches, whereas at the third level you have again 4 switches. So only 12 switches are required, and even with the 12 switches it is possible to connect any processor to any other processor in this case. So uh, but of course the number of connections that may have in this particular omega network, it may be sometimes less than the crossbar network, because a switch may be engaged in one connection, and at that time uh, that particular switch may not allow the request of the other processor to connect, even if that in that particular pair the different processors are there. So this is the omega network, which is very important for the 12 switches in this case. Okay, so like this you can have the different types of topologies. So some of the topologies, for example, I have covered in this, and you can refer to the other network topologies in the literature. Okay, so with this we stop here with the uh, network topologies. The multiprocessor benchmark, this particular topic, I will record and I will upload it on the LMS.